Oh look, a very nice bridge. What could possibly go wrong? Oh no. Wait, game 1? I guess it's strong enough. Hello everyone, my name's Dave, and this is part 2 of how to create a bridge building game 100% from scratch using C++ and SDL2. Since the first part was so popular, I knew I had to do a second one. Last time I showed you how to get the bridge set up, and this time I'm going to add a little red unit that will attempt to cross the bridge safely. The first thing to work on is a system that will detect where the road portion of the bridge is. This means that there needs to be a way to distinguish between the wooden beams and the road beams. The idea is that the unit will only interact with the road, but not the other beams, just like in real life. The easiest and most reasonable way that I could come up with to do this was to add a Boolean variable called isRoad that specifies if a beam is a piece of road or not. The next part, which is much harder, is to determine where the creature should be on the road at any given time. I can think of 2 main situations that could occur. The first is that the bridge is 100% intact and the road is completely flat. The other is where the road is breaking, meaning that the road pieces are constantly moving and could be at any angle. The first case is simple because the unit will simply move along a straight line. However, this of course wouldn't make any sense for the second case where the bridge is breaking. Obviously, the algorithm would need to work in all situations. And there are 2 main ways that I could come up with to achieve this. The first was to determine a path, a line, along the surface of the road. The idea is that the unit would be able to follow it exactly by moving a fixed amount along it in each frame. This is very easy for the situation where the road is flat, and still should be pretty easy for the situation where the road is at a bit of an angle. However, if the bridge starts to break and the road pieces are at different angles, it could be hard to determine exactly where the unit's supposed to be. The second way that I thought of was an iterative system that uses a bounds detection system to check if the unit's new position possible overlaps the road, land, or nothing at all. The unit will move along the x-axis, a fixed amount in every frame, but a variable amount along the y-axis as it gets pulled down by gravity. If the new possible position doesn't overlap anything, the unit will just move there. If not, though, its new possible position will be modified to be slightly closer to the top of the screen and checked again. The process will then repeat until either a spot without overlap is found, or a fixed number of iterations, meaning a fixed distance towards the top of the screen, is reached. While I feel that there's probably a way to get both of these methods to work, I decided that the second option was best. This is because it works really well at handling all the weird positions and angles that the road beams can be at when the bridge is breaking. The code first calculates the unit's possible position, then it checks for overlap and iterates. If the new position is okay, then the unit's position is updated. I also added a check to see if it's reached the end of the level or if it got stuck. The idea is that these checks are then used by the game to determine if it's been won or lost. Since I decided to go with the second pathfinding method, I needed to work out the bounds detection. The unit can be represented with a circle, and the road with a rectangle and 2 circles for each of the pins. In fact, because the beam has rounded corners, the entire check can be simplified to a slightly larger circle and a line, where the radius of the circle is the radius of the unit plus the thickness of the beam. The direction normal along the beam can then be calculated using basic vector math. The distance along this direction normal can be calculated for both the positions of the pins that connect to the beam and the center of the circle. If the circle is before the first pin, then a check can be performed to see if the center point of the first pin is within the circle or not. A similar check can be done if it's after the second pin. Otherwise, a check can be performed to check the perpendicular distance from the line to the circle to see if anything overlaps. I then tested it out to ensure that it worked, and everything looked good. You can see all the code for the bounds detection that implements this in front of you. The next step is to add the weight of the unit to the simulation because it's so big and heavy that it can cause the bridge to break. The first step is to determine what beams it's touching. At first, this might seem like a really hard problem to solve. However, the overlap part of the pathfinding system has pretty much already done this for us. The code that checks if overlap has occurred with the bridge and land is in front of you. When the first iteration of overlap checking is performed, it either overlaps some beams or it doesn't. The overlapped beams can then be stored on a list. The checks in the later part of the function check to see if the unit overlaps the left or right piece of land, and they use the same line circle overlap method as the beams. And of course, the land is unrelated to what beams the unit's touching, but of course needs to be part of the function that checks for overlap so that the unit doesn't fall through the land. Now that a way to determine what beams are overlapped has been set up, the next step is to calculate the forces. Recall from the last video that the simulation for the bridge itself occurs from the perspective of the pins. Since each beam connects to two pins, half the force of gravity from the beam is added to one pin, and half the force of gravity is added to the other pin. The same idea can be used to add the force of gravity of the unit. The number of pins that its force of gravity will get distributed over is twice the number of beams. The overall force of gravity that the unit applies will be divided by this number, and each pin will have that much force added to it. Note that if it's distributed over, for example, two beams that share a common pin, meaning that there are 3 pins in total, the shared pin will have this partial force added to it 2 times, while the other 2 pins will only have it added 1 time. This means that the weight distribution will be 50% for the shared pin and 25% each for the other 2. The last step was to work on the graphics. I drew an image for the red unit and also modified the image of the wooden beam to create the road beam. I then loaded the images into the game and modified the code slightly to draw each of them. As you can see, everything is working nicely. All the source code is available on my website. Link is in the description. I've also got a bunch of other games, code, and tutorials on my channel and website, so be sure to check those out if you're interested. Don't forget to subscribe for more videos, and I'll see you in the next one.